Okay, for this one, what we're going to do is we're going to learn the difference between what a permutation and a combination says. Remember, a permutation is an ordered arrangement of distinct objects, and a combination is an unordered arrangement of distinct objects. So for this one, we're going to consider letters A, B, and C. Now, if you want to imagine that you have letter blocks and you're physically picking up blocks, totally fine. You need to want to try to imagine that you're actually doing these experiments. It'll help you in the process. So what you're going to do is you're going to see 3 letter blocks in front of you, 1A, 1B, 1C, and you're going to pick 2 of them, and in part A, you're going to arrange them where order matters. So what could possibly happen? Well, let's suppose you picked one up. What did you pick up? All right, you picked up A. Then, assuming you can't pick up the same block again, what did you pick up next? All right, you picked up B. Well, there's your 2 blocks, A, B. So that is one possible way this could have ended. What's another possible way this could have ended? Yep, you could have picked up C and then B. Sure, and then you could have C and then A, and then B and then A, and then B and then C, and we need one more, A then C. Well, notice if the question was, as it says here, what are the possible ways, you're going to list A, B, C, B, C, A, so on and so forth. If they said how many ways there are, you don't have to list them all technically. You could think of this as a permutation. There's 3 total blocks, and you're picking 2 of them at a time and putting them in order. 3 permutation 2 is 6, as we can see here, of the 6 total ways. Now, to be honest, if you are asked to list things, I ask that you go systematically. Meaning what I prefer is that we say A, B, A, C, B, A, B, C, C, A, C, B. What's the benefit of doing this? The benefit is that we make sure by going down the line, we're not jumping over anything and possibly not double counting or miscounting something. Meaning that you forget one or you write one of them more than once, which would not be good. So make sure you're going systematically with this. Now, let's compare this to part B. Order does not matter. So it does not matter the order in which you pick up the blocks as long as you pick up those blocks. So you're going to pick 2, one at a time if you want to think about that way, but order does not matter. What could possibly happen? You can get A, B. Now, if you say BA, that's not going to be correct because if order doesn't matter, then AB is the same thing as BA. What else could happen? Yep, we could have AC. We could have CB. Anything else? Nope. That's it. So if order doesn't matter, then AB and BA are the same thing. AC and CA are the same thing. BC and CB are the same thing. We only have 3 of them in this case. So this is a combination because order doesn't matter. And we have distinct objects. So 3 combination 2, as we found out, there's 3 possibilities. So a couple big notes here. 1, the thing that permutation and combinations have in common is that you must have distinct objects. 2, the big difference is permutation order matters, combination does not. 3, typically for the same N and R, you're going to have more permutations than you do combinations. Okay, some side comments now. 1, to get this into your calculator, you would type in 3, and then you would go to your math, PRB, and you're looking for NCR. Now these steps are for you if you have an 83, 84 calculator. If you have a 30 series calculator, you should have a PRB button. You would hit that, and highlight the NCR and then hit enter. So if you do that so far on your screen, you should have 3 NCR. And then you would type in 2, and then if you would hit enter, you should get 3.